Now I have made a tool that will help us identify the domain and range of the graph. Okay, so as you can see, I can flip this over and I see the domain. So therefore this will give you the limit of your domain, and if there's no limit, you just open it wide and you will see the negative and positive infinity here. For the range, it's here. That means we're looking for the possible limitations of your y. Okay, let's start with the first graph. The first graph is a linear function. So in a linear function, it goes to infinity, so we open this one because it goes to infinity. This one goes to infinity, so we open that one. So your domain for this one is from negative infinity to positive infinity. By the way, this is what we call interval form. So in set notation form, we can write that as x, such that x is an element of real number. For your range, since it goes all the way to infinity, so we still open this, and it goes all the way to infinity, so it's still open this. So therefore your range is just from negative infinity to positive infinity, or in set notation for form y such that y is an element of real numbers. Now we also have another way of determining the domain and range, and we know that already by shading or extending the graph towards the x-axis. If you extend the graph towards the x-axis, you will see that it will hit all the x's here, and shade this one towards the x-axis, and you can see that we actually hit all the x's here, which means it goes to infinity. Therefore your graph hits all the x values possible. For your range, you shade your graph towards the y-axis, and as you can see, it hits all the y here towards the y-axis rather. So extend, 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 and you will see that it will hit all the y here. So therefore it goes to infinity. So therefore your domain and range is all real. And this is a parabola, and when you have a parabola, you are dealing with second degree equation, just like the example number 3. So when you're looking for range, it goes to infinity, it goes to infinity, so we let this open. So therefore our domain for this type of equation is from negative infinity to positive infinity, or x such that x is an element of any real number. And when you shade this one going to your x-axis, you can see that it will hit all the points in x, it will hit all the points in x in here. So that goes to negative infinity to positive infinity. But for your y, we have a limit, and that limit is at negative 2. So your graph starts at negative 2, but the graph continues to positive infinity. Therefore your range here is limited. Our range can only start at negative 2. So y such that y, since it starts with negative 2 and it goes to the positive infinity, it's greater than or equal to negative 2. And how do you write the interval form of that one? The interval form is that we start with the minimum, which is negative 2. Negative 2 is negative 2 part of it, yes, so you use bracket when negative 2 is third part of your solution. And then since it goes to infinity, so that goes to positive infinity. Okay, that's your range. Now observe, if you're going to shade the graph towards x-axis, towards the y-axis, when you shade that one, it will hit all the points here. When you shade this one going here, it will only hit up to here, but we can never hit other parts of y below. Next example, when you shade the graph going to the x-axis, you will see that we can never hit any negatives here. Okay, therefore since it goes to infinity, we left this open. Since we have a certain point here, limit here, so the domain starts with, and what is the value of x here? That's 0. So therefore our domain here, x such that x is going to that one is positive, so it's greater than or equal to, and this one is 0. Okay, or you can write interval form, we start at 0 until positive infinity. Okay, now how about for the range? For the y, if you're going to shade the graph towards the y, you see that we cannot also hit the negative y. We can also hit this portion of your graph. So there's a limitation. Let's see. Your range will actually start from positive 2. So therefore, your range is y such that y, we start at positive 2 until it goes to infinity, so it gets bigger and bigger, so greater than positive 2. So if you want to write that in interval form, that means you are starting from positive 2 and it goes to positive infinity. And this graph is actually just like a square root function. Okay, let's have the next one. Oh, the next one is not a function, but it's a graph of a circle. How do you identify the domain of your circle? Of course, that when you shade going to the x-axis, you'd see that we are limited with this portion. We start here, ends here. Okay, let's try to test using our interactive tool. So that means your graph ends here, but it starts here. So there's a limitation. And what is this value? The value here is -1, and the value here is 1, 2, 3, 4, 5. Your domain starts at -1 and ends at +5. So that's your domain. How do you write that in set notation form? You will say x such that x, since x is in the middle, so that means there is a boundary in both ends. So x is in the middle, going there is less than or equal to 5, because we can use 5, but less than or equal to -1. So I'm sorry for that. So if you're going to rewrite that, the domain is x less than or equal to 5 but greater than or equal to 1. Okay, how about the range? The range this time is that you have to shade it towards the y step. So when you shade it, that means you can only hit this part of your y. So we also have limit for your y, and if you use our interactive tool for that one, that means your graph ends here. Sorry, it's not too accurate, but that's a point here, and your graph ends here. So therefore, your range is limited to this y value. And how do you write that? Your range is from 1, 2, 3, -3, so 3 is part of it, to 1, 2, 3, +3. So that's your range. So how will you write that in set notation form? Y such that, since y is in between 3 and 3, so in between 3 and -3 rather, so it's less than or equal to. So this is a helpful tool in order for you to determine graphs of a function. The next graph. This is a polynomial function graph, and as you can see, the arrow goes to infinity. So we left this open, and we left this open. But in this part, we have a limitation, and that's for your range. There's no limitation for your domain, and when there's no limitation for your domain, the domain is just all real number. So x such that x is element of all real number. But you can also write -infinity to +infinity in interval form. Okay, but how about your range? Your range this time goes to infinity here, but we start at some point of the graph. So it's 1, 2, 3, 4 at -4, but it goes to infinity. So your range this time is from -4 but goes to positive infinity. Okay, so how do you write that? That will be range is y such that y is greater than or equal to -4. This is an example of a cubic function. So remember, a cubic function is when the value is raised to the power of 3, just like number 7. It's raised to the power of 3, and as you can see, the domain and range are both real number. Let's try to see if it is also possible for this one to have all real. Now, since the graph is going to infinity, this is open, and since it goes to infinity, this will also be open, and this will also be open. Therefore, there is no limitation for your domain. So your domain is x such that x is an element of any real number, or you can write -infinity to +infinity. While your range is the same, your range has no limitation. So therefore, your range is y such that y is an element of real number, and that goes from -infinity to +infinity. If we use shading towards the x-axis, then we can actually hit all the positive x-axis here. If you're using this portion, you can hit all the y's here. It goes to infinity, so we are able to hit all the y's here. That gives us all real for both domain and range. The next graph is an example of absolute value functions. Now observe that it goes to infinity, so we both open this 3, but remember there's a boundary for y. For your x, there's no boundary, so that means we can use any element in x. So our domain here is x such that x is an element of real number, which means it goes from negative infinity to positive infinity, but your y is limited. Okay, your y is limited because we start from this number and it goes down. So when it goes down, then it's becoming less and less. So our range is actually y such that y is from 2 and it goes down, so it's less than or equal to 2. So when you write that one, that will be from 2 to negative infinity. You can also use the shading. Okay, if we shade here, we can hit all these x. If we shade here, we can hit all these. And if we shade here, we can hit all the possible values of x. For your y, so if we shade your y, or we extend the graphs towards your y, you see that we can only hit this portion here. So there's a limitation. We cannot hit all the positive values of y. For your graphs here, that means these two are open because your graph is going here. So it's going to negative infinity, going to negative infinity for your y. But for your x, observe that we start here. So your x is limited from your domain x such that x, and since it's going to the negative, so it's less than or equal to, and what number is this? It's negative 1. So you will write it, since our least number is negative infinity, then we start at 1. Okay, it's still included. That's the interval form. Now how about for the range? For the range, we see that the range starts here and goes down to negative infinity. Therefore, your range is also limited. You will say y such that y, that's going down, so less than or equal to, and what number is this? It's also negative 1. If you shade going to the x value, you will see that I can only shade the portions from negative 1 and it goes to the negative infinity. If I will shade the y value, you can see that I can only shade from negative 1 goes down to positive infinity. I hope you understand the concept of domain and range based on the activity that we did earlier. See you in the next video. Bye!